Hello and welcome back to the channel Understanding Concepts of Physics. Hope you are all are doing well, and you might have subscribed my channel. In order to watch every video in detail, I would request you to go back to the playlist and watch it line by line. Today we are going to discuss about isobaric process, in which also we had discussed about isothermal process in the previous video. Isobaric process is a process in which the pressure is kept constant. So the process in which the pressure is kept constant is called as an isobaric process. It's a very simple process in which the pressure is kept constant is called as an isobaric process. So what happens in this kind of process? Very simple. Pressure is constant. If the pressure is constant, change in pressure is zero. There is no change in pressure. In such kind of process, the temperature might change, so the change in temperature is non-zero. There will be some change in temperature, and temperature and internal energy are directly related. So if there is change in temperature, then there will be change in internal energy too. So the change in internal energy is also non-zero. And dq, that is the amount of energy exchange, is also not equal to zero. So because there will be some work done, some internal energy change, so change in energy would also not be equal to zero, and change in work done will also not be equal to zero. So these are the technicalities behind isobaric process. Now let's try to figure out certain things over here. We know that Cv is equal to du by ndt. Now this is an equation which we derived in kinetic theory of gases in one of the previous chapters. So if I keep this du on one side, ndt is the term which I'll move on the other side. So I'll get nCₚdT and du as it is on one side. Now if you see, our formula for work done, that is the work done, is equal to pdv. This is one of the formulas which we use in thermodynamics for work done. And also we know that ideal gas equation is pv is equal to nRT. This is our ideal gas equation. Now if you use this equation and you write in a differential form, then you get something like this: pdv is equal to nRdt. Now how do I get this? There are two methods. What we can do is, if you see on the right hand side, n is a constant, r is a constant, and only thing can change is temperature. So if the temperature is changing, the left hand side quantity will also change. But because since it is an isobaric process, the pressure is kept constant. So if the temperature is changing, then the volume will also change. That's why I can write a d over here and I can write a d over here. And the second method is a differentiation method. If you differentiate with respect to temperature, then you will definitely land up with this particular equation. But as I said, we can just write the differential form. Change in temperature will bring in change in volume, and none other quantities will change. So wherever there is a pdv, I can write as nRdt. So in the formula for work done, I can just write as dw is equal to, wherever there is a pdv, I will write as nRdt from here. Now why I'm doing this way? Because I know that somehow at some point I'll have to apply the first law of thermodynamics. So the first law of thermodynamics is dq is equal to du plus dw. So I have to find out these two quantities, which I have already done. Du is with me, dw is with me, and now I'll apply the first law of thermodynamics. The first law of thermodynamics says dq is equal to du plus dw. Du I have already found out, that is nCₚdT. dw I have already found out, nRdt. So if you just go back to this two equation, 1, 2, then you can just put those values over here. Now to those people who might be asking, okay, what this Cv is, I would really suggest that go back to some previous videos where you will find out what Cv and Cv is. Now from this equation, I have n common, I have dt common, so I will take n and dt outside. So n outside, dt outside. What remains is Cv as it is and r as it is. So I get dq is equal to n Cv plus R into dt. From here on, I'll use my Mayer's equation. Mayer's equation says Cp minus Cv is equal to R. We have all these proven in our playlist in kinetic theory of gases. So Cp minus Cv is equal to R. I'll move this Cv on the other side. So this will become plus Cv. So wherever there is R plus Cv, I'll write as Cp. Wherever there is R plus Cv, I'll write as Cp. So Cp and as it is, dt as it is, and wherever this term is there, I'll write as Cp. This is the formula for the amount of heat energy in isobaric process. And of course, if you want to find out work done is this. If you find out the internal energy, that's this. Lastly, we are coming to the graph of isobaric process. So in an isobaric process, let's say this on the y-axis there is pressure, on the x-axis there is volume, unit is meter cube, unit is Newton per meter square. Unit is irrelevant, but yes, these are the units for pressure and volume, because this could be any unit and this could be any unit, still the graph would look horizontal. So let's say A is one initial position and B is your final state. So A is initial and B is final. So the system is going from A state to B state, that is initial to final. And the coordinates is V initial, P initial to V final, P final. So I have made a mistake over here. I can just see that since the pressure is not changing, I will not write final pressure. I would still write initial pressure because the line is horizontal, and the same pressure which is acting at this point, which is P initial, is same at this point. Yes, the volume is different at this point, I'll say Vi, and the volume is different at this point, let's say Vf. And if you find out the area under pressure and volume graph, what you get is the work done. So this is your work done. Okay, so the graph is horizontal because the pressure is not changing, however the volume is changing, so that's the reason the graph is horizontal. So lastly, PV graph for an isobaric process is also called as an isobar. So you just remember that there is a process, there is a graph of isobaric process is also called as an isobar. So that's all for isobaric process, nothing more. So thank you so much for watching. If you are still with me, subscribe the channel and share it with people who may need this, and meet you in the next video. Thank you so much. Bye.